This is the 8.1b video, and this video is going to be on multiplying polynomials. So in A, we talked about multiplying a polynomial times a single term, a monomial, which was basically distribution. In this video, we're going to talk about what to do if we have a binomial times a binomial, and then we're going to get into when there's a binomial times a trinomial. So it's not just single distribution because the first polynomial has at least two terms. So when multiplying a polynomial by a polynomial, we're going to use what is called double distribution. So we are still distributing, but we have to distribute more than one thing. If you ask your parents for help, and some teachers still teach this the same way, but kind of when your teachers were in school, a lot of them probably learned not your teachers, your parents. When your parents were in school, a lot of them probably learned what's called the FOIL method. These two things are doing the same thing, it's just kind of a different way of remembering how to do it. So if a parent or a tutor or older sibling mentions to you, oh, you just have to use FOIL, what they mean is that you're going to be multiplying the first term of each parentheses together, the outside term of each parentheses, the inside term, and then the last term in each parentheses. But like I said before, it's still the exact same process. This is just kind of a different way that we were taught to remember it for some of us old folks. I'm always going to try to remember to refer to it as double distribution because to me, it helps you understand the process of it and not just like a clue on like memorization. So this is going to help make the process of multiplying a binomial by a trinomial feel more familiar. If you only know of it as FOIL, when it gets to being 2 terms times 3 terms, it's going to feel a little bit more confusing on what to do. So let's get into our examples here. So when we're double distributing, we're going to distribute the first term in the first parentheses. In other words, we're going to multiply everything in the second parentheses by x. So we're going to do x by x, which is x squared. And then we're going to do x times negative 3, which is negative 3x. That was our first distribution, but it's double distribution, so now we have to distribute the second term. So 5 times x plus 5x, and 5 times negative 3, which is negative 15. So when you're multiplying a binomial times a binomial, after that first step, you should have 4 separate terms. And then what you're going to find most of the time is that the middle 2 terms are like terms. And this is going to happen on almost every problem you're going to see, unless there was something just a little bit different to start with. So negative 3x and positive 5x are like terms, so we're going to add those together. The x squared doesn't change. Negative 3 plus 5 is 2x, and then the negative 15 doesn't change. So this is my final answer. We're going to repeat this process with a few more examples. So for this next one, we're going to multiply everything in the second parentheses, the b minus 3 times b. So b times b is b squared. Then we're going to multiply b times negative 3, which is negative 3b. Now I have to do the distribution with the second term. And so in this one, I want to be careful. This minus means that I am distributing a negative 9. So it's negative 9 times b, and negative 9 times negative 3, so that I end up with positive 27. And again, these two middle terms are like terms. So negative 3 minus 9 is going to combine to give me negative 12b. And then I have these other 2 terms that I need to bring down. They didn't change. And that's my final answer. Going back to in the last video when we talked about that standard form, I still want to make sure everything's written in descending order on my exponents. So my highest exponent, lower, and then lowest. So anytime you have a term without a variable, that's always going to be at the end of your polynomial. In this one, these two binomials are very similar, but the sign is different. And so when we multiply, we want to make sure that we're being aware of this sign. This is a -2. We'll distribute second. So first it's 3a times 3a, which is 9a squared, and then 3a times 2, which is 6a. Now we're distributing a -2. So -2 times 3a is -6a, and -2 times +2 is -4. On problems like this, where the two binomials look almost the same, except they have a different sign here, you're going to find that these two middle terms, this +6a and -6a, end up canceling each other out. We add those together, we get 0, and all I'm left with is 9a squared minus 4. So this only has a binomial as the final answer. There's only two terms to it, whereas these had 3, or a trinomial. And so sometimes we're going to find that that happens when the middle terms cancel each other out. In our last example, we have a single binomial written, but it's squared. So this means that we are doing y minus 3 times y minus 3. And you're going to want to write that out in that expanded form before you get going so that it's easier to think about what is going on with that double distribution. So we're multiplying y times y to get y squared. Then we're multiplying y times -3 to get -3y. Now we're going to distribute this -3. So -3 times y is -3. And -3 times -3 is +9. And again, you're going to find a pattern exists when you're squaring a binomial. These middle two terms are always going to come out to be the same thing. So when I combine -3y with -3y, that gives me y squared minus 6y plus 9. And that's my final answer. So that's multiplying binomials. And we're going to apply that same process to when we're multiplying a binomial times a trinomial. We're still going to double distribute. We're going to multiply all 3 terms in the second parentheses by the first term. And then we'll go through and we'll multiply all 3 terms in the second parentheses by the second term. So a squared times 4a squared gives me 4a cubed. Adding those, oops, sorry, nope, not cubed. Let's erase that. Adding those exponents, so 2 plus 2 is 4. Now it's a squared times 5a, so 5a cubed, and then a squared times 6, so plus 6a squared. Now I'm going to distribute a -6. So -6a times -4a squared is -24a cubed. -6a times 5a is -30a squared. And -6a times, whoops, that did not go to the right place, times 6 is going to be -36a. I have 6 terms now because I multiplied these 3 by both of those, and now I need to go through and find my like terms. So I have 2 terms with a to the 3rd, so I'm going to be able to combine those, making sure I don't lose the negative sign there. I have 2 a squared terms, so I'm going to be able to combine the 6a squared and the -30a squared. But the first and the last term are not going to have any like terms, so they're going to stay the same. So 4a to the 4th, 5 minus 24 is going to be -19a to the 3rd. 6 minus 30 is going to be -24a squared. And then I have this final term that didn't combine with anything. So in this case, it was the middle 4 that combined. The first and the last stayed the same. It's not always going to work out exactly like that, but usually you'll have some things that combine. All right, this is our last example. So we are going to distribute 2w squared to w squared, which gives us 2w to the 4th. 2w squared times negative 5 is negative 10w to the 3rd. And 2w squared times 10 gives us 20w squared. So we distributed the first term. Now we're going to go back and we're going to distribute a negative 5. So negative 5 times w squared, negative 5w squared. This is a negative times a negative for the 5, so this is going to become positive 25w. And negative 5 times 10 is negative 50. When we look for our like terms, there is no other w to the 4th. There's no other w to the 3rd. We do have 20w squared and negative 5w squared. But those look to be our only like terms. This is the only term with w to the 1st, and this is the only constant. So these are going to be the only two that we combine. So we're going to end up with 2w to the 4th minus 10w cubed. 20 minus 5 is 15w squared plus 25w minus 50 on the end. And that's our final answer. That's a pretty long polynomial there. It's got 5 different terms, but we've combined everything we can. Our variables are in descending order according to their exponents, since they all have the same variable there. So that's the last of the notes for this week. If you want to go ahead and make sure you get some practice from the bottom row, practicing your multiplying binomials and multiplying binomials times trinomials.